This is a video to go over the Unit 7 Logistic Model Understanding Check that you turned in last week. I'm going to treat this the same way that we would treat homework in class, so it's basically a completion grade and then we go over it together. So you won't be getting individual feedback in Google Classroom. You're basically just going to get a grade. I'm going to look at your assignment, look and see if it looks like you tried, and then you'll get the full credit. So don't expect individual comments on that, so you should be using the answer key and these videos to adjust your understanding and fix your mistakes. So we have this differential equation, dp dt is 0.0375 times p times 20 minus p. And this is the model that you would have used in the rumor spread if you had actually fit a model. We're going to suppose that p of 1 equals 2 and find the tangent line to the graph of p at t equals 1. So the thing that we need to remember is that our ordered pairs are of the form t comma p. In order to find a tangent line, we need a slope, and right up here in our differential equation, that actually gives us our slope. So down here in part 1, I did dp dt given that p equals 2. Now, we could have plugged in t equals 1, but notice there's no place to plug t into. So I'm just going to plug 2 in for the p, and I get a slope of about 0.135. And then I'm using that ordered pair 1 comma 2, and I'm putting that into point slope. So right here we have our point slope equation, and if you'd like you can change it to slope intercept form. Now part 2 gives you a particular solution. It wants you to show that it's a solution to the differential equation with p of 0 equals 1. You don't need to solve, so there's no separation, there's no integration, you're just showing that it's a solution. So what does that mean? Well, first let's check the initial condition. So checking the initial condition means plugging 0 into the t into this equation and seeing that you get 1. So down here in number 2, p of 0 is 20 over 1 plus 19 e to the 0. E to the 0 is 1. So down here 1 plus 19 is 20. 20 over 20 is 1. So the initial condition is satisfied. So the second part to checking is the verification, so plugging into the differential equation. So I need to first calculate dp dt because that's the left-hand side of the differential equation. So I'm taking the derivative with respect to t of my proposed solution. So this is my p right here. So taking the derivative of p, and notice that I rewrote it in exponent form so I didn't have to use a quotient rule. I will need to do the chain rule. So I do the derivative of the outside at the inside, so that means bringing this negative 1 down and then subtracting 1 from the exponent, which makes it a negative 2. And then I multiply by the derivative of the inside, which requires the chain rule twice. So derivative of the exponential function is the exponential function, and then I multiply by the derivative of negative 0.75t, which is negative 0.75. Then I just multiplied the coefficients, kept the e in the top, and then moved this negative exponent down to the bottom. I could have also moved this negative exponent down as well, but I just left it like that. So moving on to the next page, which is checking the right-hand side. The right-hand side looks like this, 0.0375 p times 20 minus p. So I'm just plugging in the proposed p, the one that was given to me, in these two places, here in the p and there in the p. So here and then right here. And then it's a bunch of algebra. So in this factor, I need to get a common denominator. So I'm going to build up this one to have the common denominator. So I multiplied by the denominator, and you notice these 20s cancel, and then I have the denominator showing up twice, so that's what gives me this square. And then I just did the 0.375 times 20 times 380, and that's where I got this 285. And that exactly mimics the left-hand side, or matches the left-hand side that I got in the first part of this problem. So when I got that the left-hand side and the right-hand side were the same, that is a true statement, so that shows that it satisfies the equation. The last part is to talk about what happens to the equation in the long run. So in the long run, we're talking about the limit as t goes to infinity, and this is kind of going all the way back to Unit 1 when we did limits. So I'm taking a limit as t goes to infinity. If the limit of the top and the bottom exists, you can distribute that limit to the top. And furthermore, you can distribute the limit along the sums and through constant multiples. So what I've done is I've applied this limit sort of to the numerator and the denominator, and then within the denominator I applied it to the separate terms, and I also brought the constant multiple out in front right here. Now what we notice is that as t goes to infinity, e to the negative infinity is basically going to be 1 over infinity, which is going to go to 0. So remember, when you have a type 1 over infinity, you get 0. So I get 20 over 1, which is 20.